Hi, hello, namaste, welcome to Pardus tutorial. I'm Madhavi, and as you know, in this Pardus tutorial, I'm uploading the videos which are related to the physics topic and which are useful for IIT exam, JEE exam, and as well as the all the students for all classes from 62 up to degree and BTech, and for all classes also this will be useful. And now we'll see. And now which means today's topic, previously I have done the four more videos of the same topic which are about the reflection of light, right? So in the reflection of light, reflection of plane mirror, and that is I have explained in the first video and second video, which are about reflection and loss of reflection. I have explained in the plane mirror, which means plane surfaces. And next video I have explained about the spherical mirror and what type of spherical mirrors are there. And the last video I have explained about the ray diagrams of two different types of spherical mirrors. One is concave and another one is convex. So we have seen different types of ray diagrams, which means what are the ray diagrams in a concave, convex we have seen. So in that using that ray diagrams only, so if you are using first rule and one light ray will be reflect, second rule another light ray will also be reflect, right? These two reflected rays, not only first and two, you can take any number in order to form an image. In order to find out the image formation, we have to compulsory draw the any two ray diagrams, which means to minimum number of light rays are required to intersect, means two only na. What is the minimum number of light rays required to intersect? Two are required, not only one. That is the reason. There are many number of light rays are passing from, suppose on me, many number of light rays are falling on me, and these are reflecting to other eyes who can able to see me. So this reflection process will be happening with a many infinity number of beams of light will be comes to us, whether convergent, divergent beam and parallel beam. All types of beams of light will be pass. But here in the case of the ray diagrams, so those any two ray diagrams we have to use. In that four, any two we have to use, first and fourth, second and third. One times we in some cases we can use the first only twice and second only twice, no worries. Like that also we can take. But any two light rays we have to incident to the mirror, and those reflected rays should intersect at one point. That point we have to take as a point of image formation. So we'll see that type of image formations in the case of the concave mirror first, and the next video will about the convex. We'll see there are 6 cases are there. I already said you in the case of the concave mirror, if you are keeping a point at different position, which means not point, if you are keeping an object at different positions, based on the position of the object, the type of image will also be changed. So we'll see the first case. First case, the image is forming, the object is at, I am taking case 1. Today's our topic is image formation in concave mirror. Image formations in concave mirror. So we'll see the case 1. Case 1. So now, okay, if you are taking a light ray, this is the concave mirror, center of curvature, exactly in between we have to draw, and this is the focus. So now, first case, object at infinity distance. The best example I can say to you, there is one experiment also. What is that experiment? If you are there is 2 candles you have to insert to a sponge, not 2 candles, 2 nails, iron nails. Yes. Sorry. Here we have to keep a light source, a torch light. So you can observe the shadows other side, right? If you are keeping very closer, the shadows will be formed like that. The shadows of these nails will be formed like this. If you are moving this torchlight little backwards, the shadows will be formed like that. If you are moving the light source which is away from the iron nails, as soon as the distance is increasing from these nails, the shadow of these lights will be straight, which we can observe. The parallel light shadows will be formed, which means if the distance is increasing, so the shadow is straight, means shadow is straight means what? The light beams of light, beams of light also will be passing parallel, which means shadow is passing, shadows will become parallel, means nothing but the beams of light which are passing, which are falling on this iron nails will also be coming in a parallel light or straight beam. That is we are calling parallel beam. This one experiment is there in the 10th standard, in the 10th class only, in the same manner. Now the object is there at where? At infinity distance, which means far away for this mirror. So for this mirror, the object is there at infinity, which we can see the light rays will come in parallel. So I am using the first rule. If the incident ray is passing parallel to the principal axis, yes, after reflection it will pass from the focus. It passes through the focus. It passes through the focus. And next parallel light ray I can also take here, I can also take here, and I can also take here. So now here this is R1. Next another incident ray which is I2. This is also parallel. Why? Because the object is there only at the infinity distance now. So now parallel. Again this will also be reflect by passing through the focus. Yes. So here these two reflected rays are intersecting at the point of focus. Am I clear? These two reflected rays are intersecting where? At the focus. So now here the reflected rays are really intersecting now. So exactly this is the point where the image is formed. In the same manner, if you have a doubt, you can just take the concave mirror and keep an object there at infinity distance, and you can try to observe the infinity distance object. Those image will be formed exactly at the focus, which means at the middle, in between, that to be a point size image. And here you should have to write properties of light. So now here I am just writing in a word, but in the examination you have to write properties of image. A proper heading you have to write, and the sentence also you have to write, not only a shortcut words. So here you have to write image is real. Yes. Next position of image also you have to write. And in the case of the image formation, how much marks you are getting to draw this image, and the same marks you will be scored to the write the properties of image. Compulsory you have to write the properties of image. In the properties of image, mostly you have to mention position of the image, where the position of the image, and second one whether that is real or virtual. Third one erected or inverted. Yes, same size or larger, like that. These four things you have to observe. Yes. So here position of the image at focus you have to write. I am directly writing at focus, but you have to write the position of image forms at focus. You have to write like that. Next, which is the image is real and the image is inverted. Real and inverted. If you observe, you can also ask one doubt. Here can we see whether that is inverted or real? Yes, of course it is inverted only if you can observe that image with using microscope or anything, but it will be inverted image only. Real, whatever the real images, compulsory those will be inverted images. Am I clear? So now the third point. What is that? The size of the image. Real and inverted. Size of the image is point sized. The size of the image is point size. You have to mention like that. Am I clear? These are the properties of image in the case 1. And now case 2. We'll see the case 2. Yes. Okay. We'll see the case 2. Case 2. Object at object is not yet beyond C. We can see beyond C. Object beyond C. Pole, center of curvature, focus. Now what I am telling, the object is there beyond C, which means backside, behind C, backside of C. So now I am keeping one candle. I am taking one candle. A candle I am keeping here. Where I am keeping beyond C. So now from this, if the mirror is here, suppose one torchlight I am keeping here. Okay. Some are slanted light beams will be fall on the mirror, and some are the parallel will also be fall, right? In the same manner, here also some parallel will come and some slanted will come. Yes. So now first rule I am using, the parallel beam of light is coming, parallel light ray is coming. So if it is passes parallel to principal axis, first rule, it will passes through the focus. Yes. Next case, if a second rule I am using here, if the light ray passes through the focus, after reflection it will pass parallel to principal axis. Am I clear? This is the principal axis now. So where the intersection of these two, see, this is I1, this is R1, this is the I2, this is R2. This R1, R2 where are intersecting? Here, right? So here a small candle will be formed. Candle, the same whatever the object here, from where we have to draw, at the point of intersection, from that point to exactly principal axis. From there to there we have to draw, not from somewhere else. Yes, up to there only. That is only limit. So now if you observe, the object size is this much. Image is forming smaller than the object. And where is the position between F and C? Yes, and how it is forming? See, which is a forming by the intersection of real reflected rays only, and also this is a inverted. Yes, inverted. So now properties of image. Position is between F and C. Next, you have to write a statement in the exam. Don't write like this in the point wise. Okay. Second one is a which is a real image only, and also inverted image only. We can observe it is an inverted image only, real and inverted, and size smaller than the object. Yes, smaller than object. Am I clear? Smaller than object. This is the case 2. Yes, we'll see the case 3 also. Am I clear, all of you? Now we'll see the case 3. So we are keeping beyond C. Again we are keeping little closer, which means at C, at center of curvature I am keeping an object. At center of curvature I am keeping an object at C. C means at center of curvature. Now the same concave mirror I am taking. This is the pole, and this is the center, this is the focus, this is the principal axis. So now I am keeping an object. So now I am just taking as example as a candle. You can take a tree, bottle, showpiece, or pen, eraser, any object you can take here. But I am taking as a light source candle here. So if you see, from here also again I am using the first rule. If the light ray passes parallel, it will be passed from focus. Again, if the light ray passes through the pole with making some angle, it will also passes from the pole with the making equal angle. So intersection of these two rays will happen at here, which means from point of here to here, if you are drawing a candle, the size of the candle will be formed this much. Am I clear? Which means we can understand the size of the image is enlarged. The size of the image is enlarged. Am I clear? Not magnified, enlarged. So we'll see the properties of images, where the object, the image is forming beyond C. If you observe in the previous case, sorry I erased. If you observe in the previous case, if you are keeping object beyond C and the image is forming, I'm so sorry. Object at C. I'm so sorry. Again, I'm drawing. If you are keeping an object at C, it will be passes through the center of curvature. Again, one more incident I am taking. Yes, it will from the with the making. The intersection will be happen exactly at the center. I'm so sorry for the last one. So now we'll see. Here we are keeping an object at center of curvature. The same position the image will be formed, but with the same same size and also real and inverted. Yes, the position of image is also at C. Yes, and which is also real and inverted. Which is also real and inverted, and what is another one? Same size, which will be formed same size of the image. That is the reason if you are taking a especially concave mirror, you are keeping same at the center of, if you know the focal length of the lens, the mirror, so the double of it is a center of curvature. So at that place if you are standing, so you will be get the same size of image. How much size of the image you are keeping, the same size it will be formed, not bigger. Yes, so in the same manner. Next, case 4. Case 4 is object between F and C. Now little closer I am taking. Now see, now next case I am keeping an object between F and C. Am I clear? So now see, this is a concave mirror. Now I am keeping an object between F and C. So now same one parallel light ray I am taking, which is passes through the focus. Fourth rule I am using, which is here intersection will be takes place. So from there to there, if I am drawing the image, so see. So sorry, before the case I have explained that one. Fine. So if you are keeping an object between F and C, image is forming beyond C. If you observe the second case, if you are keeping an object beyond C, image formed between F and C. But now we are keeping an object between F and C, image is forming beyond C and little enlarged. Yes. And properties beyond C, image is forming position beyond C, and real and inverted, next enlarged, little enlarged one. Yes, this is a case 4. Case 1 at infinity, case 2 beyond C, and case 3 at C, case 4 between F and C. Now the another case, I am taking the object little closer to the next case, which means at F. So in between F and C, wherever you are keeping an object, here, whatever, if you are keeping the object between F and C, which is closer to F, closer to C, whatever, the image compulsory will form beyond C only. Am I clear? So now the next case we'll see if the object is there at the focus. Am I clear? Now case 5. Yes. Now case 5. Object at focus. So for our first case, just you have to remember that one. See, focus. If our object is there at focus, I am keeping an object at focus. Okay, it may not be a light source. It can be any object. Okay, you can keep any type of object. Okay, I am not using the first light ray. I am using the second case. Second case I am using here. The third case. So in this, In these, if a light ray is appears to be passes through the center of curvature, it will be reflect along with the same line. Yes, this is a one light ray. Next, if the light ray passes through the pole, after reflection it will be reflect from the same point with the making equal angle. Yes, so with the making equal angle. But here if you observe, these light rays are not intersecting, but those may intersect anywhere, because if you are keeping object at infinity, image will be formed at focus. In the same manner, if you are keeping object at focus, image will be forming at infinity distance. In the same manner, if you observe the light rays, as soon as those are appear for us in a converging, those may converge somewhere but not diverging. If those are diverging like this, one is like this, one is like this, we cannot predict those may intersect anywhere, right? So but those are appears to be converged somewhere, but those are not intersecting here, but those may intersect at somewhere. So that is exactly, we don't know where is the position. That's the reason we are telling that image will be formed, but where it is at infinity distance. Position at infinity distance. The image will be formed at infinity distance. Yes, and of course it is a real and inverted only. Of course it is a real and inverted. And how it is, as soon as the distance of intersection is increasing, the size of the image will be enlarged more. That is the reason it will be highly enlarged, because we have to draw the image from the principal axis itself only now. Downwards we have to draw, so it will be highly enlarged. It will be highly enlarged. Am I clear? This is the case 5. Now case 6, object between, which means next case what I am doing, I am keeping the same object between P and F. That is only last case. This is the last case, between P and F. Okay, so now the same concave mirror I am taking. Okay, here is center, here is the focus. I am keeping an object in between F and C. So now one light ray passes through the pole, and it will be passes with the making equal angle. And if the light ray is and appears to be center of curvature, it will reflect along with the same line. Am I clear? Here if it is appears to be passing through for center of curvature, it will be reflecting along with the center of curvature only, because if the light ray passes from the center of curvature, again it will be reflected along with the same line now, like that. Am I clear? So now here if you observe, here the light rays, which means reflected light rays, appears to be diverging. Before a case I explained now. So if the two light rays appears to be diverging, so those may not intersect anywhere now. So that is the reason what I am doing here. We have to take a scale and extend these light rays backwards. Yes. Okay, straightly you have to extend, not like this. Okay now, here the intersection will take place. So this is a where the position of the image. Okay. So here image is forming behind the mirror. Behind the mirror it will be formed, and it will be virtual, because it is not forming by the real reflected rays now. This is also some important case. It will be virtual, and also wherever the image is virtual, compulsory it will be erected only, not inverted. So it will be erected. Next it will be magnified image. It will form a magnified image, little bigger. Am I clear? Bigger than the size and magnified image it can be formed. Am I clear? So this is the case 6 and final cases. These are the totally 6 cases are there which are very important for your 10th class. And based on this, sometimes they will give one case and they will ask you to draw the image formation. Sometimes they will tell you like that, if we are keeping an object at center of curvature, then draw the required image, required the ray diagrams to form an image, which means image formation only you have to draw. And also many questions they can ask. So here, based on the position, there is another thing will be there, and how to find out the magnification, everything will be there, and will be explained all the topics slowly, which my concept is to make you understand clearly. That's it. Yes. So now that's all about the image formation in a concave mirror, and we'll see you in the next video with the image formation in a convex mirror. Those only 2 cases are there. We'll see you in the next video. Until that time, please keep watching the video, keep watching the channel, and subscribe the channel, and press the bell icon which is there, and you will be get the notifications of my videos, newly uploading videos. And subscribe the channel and share the video which is useful for the remaining people, okay, who are preparing for the exams. So share the video and subscribe the channel, and thank you for watching the video, and thank you.